Okay, similar idea here. You'll notice that we have a slightly different function here. We have a radical. It doesn't change our general process, but so if we look at this, let's start off with f of g, right? So that means f is our skeleton here. It's our structure we're working with. So we're plugging in 2x plus 5 everywhere we see an x in this function. So we've got 2x plus 5 minus 1 underneath a square root. So that gives us 2x plus 4 as a final answer, okay? So in looking at this, again, we need to look at the domain of this function on its own merit initially. So because this is a radical, the radicand, the inside, cannot be equal to, it needs to be non-negative, so it's 0 or larger. So we take that 2x plus 4, the radicand, the inside, we set it greater than or equal to 0, okay? So the 4 goes to the other side, greater than or equal to negative 4. We divide, so that's negative 2. That means our domain is negative 2, infinity. If you look back on our original question up here, for g of x, you'll notice that there's no difference. There's no restrictions on this, right? Because this domain is all real numbers. So there's no change attached to it. So our final answer for our domain for this question is right here. Okay? For our second one, we have g of f of x. So we're plugging f of x into g, right? So you've got g of the square root of x minus 1, which gives us 2 square root x minus 1 plus 5. So there's not actually any simplifying we can do there, so we just kind of stop here. But we do want to consider the domain of this function. So again, my main focus is on the radicals. So we take that x minus 1. It needs to be greater than or equal to 0, which means x is greater than or equal to 1. And that gives us a preliminary domain of from 1 to infinity. Now, again, we look at f of x, it's the interior function, and you'll notice it has the same restrictions. We also need x minus 1 to be greater than or equal to 0, and we already did all of the work for that right here. So there's no change to our domain. It's just bracket 1 to infinity.